So the plot that we're going to use for the class is because this is categorical variable, right? Eh? This is categorical, right? And we want a univariate plot. So what's that one going to be? Is this scatter plot? I haven't forgotten. I wrote them on the plot yesterday. I think it should be cat plot. It should be cat plot. Or I would use documentation. Seaborn. Huh?
Is it for univariate?
Yes, for univariate.
You talk about cat plot, this plot.
It's cat plot. It is for numerical value that we now use dist plot. Are we there?
Okay, it's cat plot, not
Cat plot. Is it count plot? Let me check though. Count plot, right? Yes. Is the other one that is cat plot and rel plot. I really wouldn't keep them on my head. So let me see. Yeah. Count plot, box plot, routing plot. Okay, so let me see. Count plots, dist plots, KD plots. Alright, so since that's it, I'll just go SNS. Do I have SNS before? Do I import SNS before? Yes, it's already imported. SNS dot count plot. What do we need for our count plot? X, right? We need to pass in X. So what's our X going to be? Label. Do we need any other thing? We don't need Y because it already knows. Then I'll pass, I need data, right? Equal to, my data is DF, right? Yeah. Have I rerun everything? No, let me rerun again. Let me see. I hope this works. I hope this works. I hate to see these red lines. Yes, it does. Are we here? You know what this one signifies? Huh? Can we translate this? Yes. Can we translate? What's this plot signifying? I'll need to turn this one. This one is telling us that the data set is balanced now. Every crop has 100. Yes. The rice. Do you remember the code for turning this? For turning the label? Do you remember the code? We turned it let's say turn seaborn S-tick by 90 degrees. Let me see a code that will do it. Okay, rotate axis tick labels. You see, if I click on this, I should have a code that will do it somewhere. Is there a code here that does this? How to rotate by 90. This idiot always brings. I'm not signing up. Go. Yeah. Fix size. S-tick. Yes, this is a code for it. PLT X-ticks rotate 95 degrees. So if I copy this, if I paste it, it should rotate that. If I drop it down, put it. If I enter, I should have it rotated. Do you see? I'm not rotating by 45 degrees. I want to rotate by say 90 degrees. Right? You know, 45 degrees is just 90 so that it will come straight. So that I can see what is there. Exactly. So you see rice. We have rice, maize, chickpea, kidney beans, pigeon beans, all of them being equally represented. Are we there? Eh?
Let's see, let me see.
PLT. This ones is called, they are called sticks. Okay, another thing I want to do is I want to add the title to my visual, right? Eh? I want to add a title. What is this plot for? Even if it is already here before, but you should still add it to your, in case you want to make a presentation slide. You would not want to be using another this thing, picking, you can just crop this or save as PNG set. There's always a save as here. You can just save it and use it as well. So let's add a title to it. So how do I add a title to this? How do I add a title to this? I think it's plt dot title, right? And notice that all of them are coming before I actually did the plots. Do you notice? All of them are coming. All the formatting are coming. You first do all your formatting before you now make the plot. Plt dot title. So I'll make it say distribution. Distribution of crops. Are we there? In the data set. Distribution of crops in the data set. If I run it, are we good? We have a title. There's how you can format this title. Just Google it. There's lots of formatting for it. You can change the color of your title. You can add space between your title. Let me Google so I see an example. Add space to math plot light, right? Title. You see? But this one is using axis. Why is this one using axis? Increase distance between title and plot in math plot light. Okay. Just write your English and send. You see something I did. But for cramming all this formatting, this thing is really not my thing. Okay. Can we use PLT to set title? These ones are using axis. Okay. I think I will just use this. Let me copy this. Let me copy this and use this instead of the title. Sherry, did we use title that last time or we use super title? Let me use super title and see. I'll remove this, then I'll do this. You see? It worked, but it's too much. Why? So I'll just reduce this, say 1.0. Let me, yeah? I can make it 0.8 or 0.9. 0.99. Yeah? Yeah, something like this. You see? Are we good? Alright, then my findings here. I will now explain it under. Are we there? I will explain it under. Let me add a text here. What did I notice here? The data set is the crops. The crops in the data set is evenly distributed. All the crops have 100 entries. 100 entries each. Now, what's my pre-processing suggestion now? There is no need for any pre-processing, right? In this regard. Are we good to go? Then I'll go to the next subheading. I'll go to the next subheading. I would have, let me see, let me copy this one so that it will be the same size. Ctrl C. Go to the next subheadings. Then I'll now do predictor, predictor variables. All right. In this, all these ones, I think all these ones are numerical, right? Yeah? I think they are numerical. I think they are numerical. Yeah? All of them, right? All right, so let's look at them. So in this, that is categorical, right? All right. In this section, are we there? In this section, we consider the distribution of the predictor variables. Eh? Unnamed, right? Okay. Okay. Yeah. Are we here? Okay, in this section, we consider the distribution of the predictor variables, right? What is our objective here? What is our objective there? What is our objective in this section? You know the objective in the first section, where we consider the distribution of the categorical variable. The objective there was to ensure that the classes are balanced, right? In this section, the objective here is we want to understand the data sets. Are we there? Should this distribution change in the future, it is going to affect your predictions. Are we here? Did we get it? Did we get it at all? No? Now, this is an explanation. I actually explained this last class. This one might not directly affect, because even if we get it that the distribution is not this thing here, there's really no much we can do around this part of it. Are we there? But we can stay here we can do this to understand how the data set is actually distributed. How do I explain this one? Okay, this is an example of how it can affect you. I made this example last class. If we have a data set, right, where we have a column in the data set, are we there? Sex, or we have sex, age, right? And when we trained that model, we were training on male of age 17 and below. Probably that was what we want the application to be for. Are we there? Now, if people now start using it, they will now observe that the performance is degrading. They want to know what happened to your model. Are we there? Why is your model not performing well? Now, it might be that probably aged persons have now been using it. Did you get that? It's common. It's common. I build app for younger children. For example, I built an investment app for younger children. I want them to learn investments from young age. As an example now, do you get the idea? Your target is secondary school below. Are we good? So you are trying to now predict, probably inside the application, you are now trying to predict person's IQ at the end of using the app now. I built it for 17 below. Did you get the idea? Now, when the app came out, elderly persons now find it useful. Why alaye bang bekini? Did you get the idea? And what your application is now recording as the prediction for the IQ wouldn't tally because these persons are elderly persons. Are we there? They already have that IQ already. It's just for them to get, so they will get it a lot easier than the younger person. The performance of your model is going to stagger in that kind of scenario. That's because the distribution has changed. Are we good? So when you now plot it and compare it with what you trained on, the data set that people are using on it, then you now compare it to what you trained on, you will be able to figure out what is wrong in time. Because I did this model, I know the nature of the data set I used to train it. Did you get the idea? It's still within the scope of EDA. Are we here? I still made another example last week. COVID. Do you remember that example? How it can affect bank applications. Did you get the example? I built a bank application where normally people will come to counter. When COVID came, people don't go to counter again. I'll have more online transactions now. Did you get the idea? Imagine that my application is now detecting most of them as fraud. Because probably what I trained my model on it before, my model is identifying that when people don't carry out large transfers online, right? If I want to do, for example, if I want to do 10 million naira this now, I would prefer to go to bank. I don't want you to say my money and go. But with COVID now, there's a chance that such big amount of money will be carried out online. Imagine that my model starts flanking it. So when your data set, when your distribution of your data set shifts, the performance of your model will shift. So it's better you understand the distribution of your data set, have them figured out while you are doing the model. Are we there? So let's see how we can do this. And consider the distribution of the predictor data variables to understand the nature of the data set we are training on. Okay, now I think this is where you help me with code. What did we do last week? You know, we gathered all of them and plot all of them together, right? I remember that we created a figure and an axis, right? Yeah, because now we need a figure for multiple and we need multiple axes, right? So I'll go figure, comma, I think I should still remember this, equal to PLT, right? I'm using Matplotlib now, right? PLT dot angle PLT dot do we use subplot or figure? We use subplot. Eh? PLT dot subplots. Okay, subplots. Eh? So I now create how many? Adjust? No. We are not adjusting now. Sheriff, you should have last week's notebook. Last week, the notebook, you should have it. Eh? Feed? Okay. This, you are starting from subtitle. I want to create multiple plots. Eh? PLT dot the size. I want now this is how many? I want to plot how many plots now? I want to plot for nitrogen, right? Phosphorus, 2, 3, 4, 5, 6, 7. 7 of them. I don't need to plot for this one because I know that they are used. 7, right? So I can do 7. If I do 3 comma 3, that's 9. 3 comma 2, that's 6. 3 comma 3 will be fine. Right? So let's go 3 comma 3. Are we there? If I run this one, what would it give me, sir? Yeah, I think I have the subplot. Now, did you get what's happening there? We wanted to create multiple. Yeah, for each of them. I don't want to create them one. You know, I looked at in the first place, I looked at the label. That's our target variable. Now I want to now look at the predictors variables, all of them. The same way I did this one. But it is going to be annoying if you are now scrolling nitrogen, phosphorus, sulfur, calorie. Imagine that they are 50. So I now want to do them together, like so that they would yeah, in case even if you are making presentation, you can just pick out this thing like that and just have it in one slide for your presentation. It's better this way. All right. Okay, I think we need to adjust some things first, right? Like the spacing. Do you have a code for that? Eh? Okay. What the exact code? I don't remember the. Eh? Okay, fig dot subplot underscore adjust, yeah, in brackets, okay, h space equal to 0.5, comma, w space equal to 0.2. If I run it, has no attributes, subplot underscore adjust. No attributes, subplot underscore adjust. So this is not correct. Eh? Or is it axis? Eh? It's fig. And that's what you have to, Sheriff. Eh? Subplots. Yes, subplots underscore adjust. Yes, now we are talking. Okay. Did we created the size? I think we increased the size. How did we increase the size? Okay. This wasn't how our destiny was looking last week. Sheriff, you should have the notebook now. Check. Let me Google. Increase the fig size of subplots. And C1. Let's see. How to adjust subplot plan, okay? Yeah. See the code here. There is a fixed size that we didn't add. So I'll just add it. Control C, Control V, comma, fixed size, 12,5. This is going to be awkward. Yes, this is looking better. So I'll make it the height. I'll change the height to 7. Let's see. Is it better? Let me change it to 10. Yeah, I think this looks good. Right? We have the size. Yeah, right? Please. That's why I want us to work. I want us to work on this notebook pari passu. There are always things that you can always pick from there. Like if I'm doing this on my own, I am sure that if I go to any of my notebooks, There are lots. I'll get lots of them. All right. We are good, right? Okay. Huh? What's the error? The error that will determine. Yeah, there's something wrong with this. Eh?
Okay, pick, comma. See, is it pick, is it pick? The first one is pick, comma.
AX.
AX. Equals to plot, the subplot, then bracket 3,3. Then pick size.
Do you have comma after this last three?
No.
Yeah. So when it's a syntax error, it is not a code something, it is the rule that something has been broken. Yeah? Are we good? Alright. Now we have gotten this thing. The second one is we need to add a title, right? To this whole plot, right? So I can copy the code for adding title here, right? I'll copy this one. Then I'll place it here after this one. I'll place it like this. plt.supertitle, distribution of predictors, right? If I run this one again, do we have it? Yes, but it is now far away. So I'll reduce it again to say 0.9. 0.92, 0.94. Yeah, I think it's good this way, right? Nice. All right. Then we can now start putting each one of them. Remember the axis. What is the axis of this one? This is 0, 0, right? 0, right? 0, 0. Row 0, column 0. Row 0, column 1. Row 0, column 2. This is row 1, column 0. Row 1, column 2. All right. So I'll plot nitrogen in the first place. Right? I'll put nitrogen here. So I'll say, so which kind of plot do we plot now? It is numerical. Yes. Eh? SNS, right? Dot dist plot. So we'll pass. S equal to, it's like this plot, we are passing the whole data into it, right? S equal to df slash, are we there? Nitrogen, right? How do they spell that nitrogen? I'll just copy it here. I'll come and paste it here. I will now remove this one. Yes, any other thing? Then I'll now pass axis into it, right? Axis equal to AX. Which of the axes do I want to use? I will tell it which of the axes. Because I've created, remember that I've created multiple axes here. Eh? So if I'm now creating for each one now, I will now be passing in the axis that I want. So this axis now, I want to put it here. This axis is going to be 0. Are we there? Which is the first one. It's telling us that it's on row 0. Now row 0, column 0. That's my axis. If I run this now, what would I get? Yes. Appeared. Are we good? So run again. Where is this one? I hate this red notifications. All right. I think this came out well. Are we there? But we still need some formatting. Are we there? Are we there? We need some formatting. Now those formatting are going to be, we need to add the subtitle. We have supersite title here, But this person will not know that this plot is for nitrogen. So we still need to add that to it. So how do we add subtitle? Now this will come after the super title now, right? After we added the super title. For each one, we'll be putting their title before we make the plot. Put their title, make the plot. Put their title. So how do we make the title for this one? Add the title for this one. Dot set, right? Still in the same distance. We just put dot set there, right? They will now have title, right? Okay, title equal to, right? Title equal to, So let's put nitrogen. So if we go there, yes, we have nitrogen appearing as the title here. Are we there? Are we good? Now, what is this part set? What is it? Yeah, we don't need to add. Do I need to add anything here? The density. Okay. What would this place be called? This place will be called the amount. Right? Because this place is the count. How plenty are they? Yeah, nitrogen is title. The nitrogen, well, if that will make it look good but I doubt it. I think this one will be fine too. Although you can increase the size of this. Yeah, you can increase the size. One way to do it, check Google online. GPT can help you too. Yeah, so I'll just do something like this, because if I do something like this, this is my code, I'll do something like this, increase the size of the title, definitely to do this, yeah. So set title, you see, AX set title, nitrogen. Okay. So do I need to add this one? Axis set title. But if I go axis set title, okay, let me see. I think this is the only code that is missing from what we have. So if I copy and paste it here, let me see what happens. Yes, abstract attribute set title. I know that's going to look somehow. Let me see what it wrote first. Figure axis, this plot, okay. Your set title. I'll just remove it. But if you still copy that error, still paste it, you adjust the code. Control Z. Are we here? So I'll not waste so much time on that. Alright, so we are good. Oh, okay, are we good? Is it this plot or this plot? Come in. Let me try this. Didn't work. See what I did? Doesn't allow the S parameter. You may wish to try hist plot. Hist plot. Let me try hist plot. Hist. 0, 50, 100. Hist plots. This is not bad as well. Well, I will still prefer to go with dist plots, distribution plots. Yeah. Yes. Are we good? 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 I don't like seeing this red thing in my notebook. Let me go and silence it. Silence, silence, Jupyter notebook warning. Notebook warnings. It's going to give me a code I can add to the heading. Yes. Import warnings, silence the warnings. So I'll just copy, paste in my notebook, and my warnings should be silent. So I'll just come down here, paste, load it. Don't want all these annoying red warnings. Yes. You can just Google as well. Silence Jupyter notebook warnings. Then okay. So the next one, let's plot the next one. I'll just copy. Oh, you say we added X and Y title, right? So SNX, what's the code? .x title, right? .x title, let me say, no, it's not title, label, X label, right? X label, okay.
So where do we add that? We add it at the top. Where
Yeah, you know, see, okay, yeah, where we are importing, yeah. Now note the format of this plot, right? Before you actually call the plot, the exact plot that you want to format, the code that you are using to format it should come right before it. Did you get the idea? So I can have multiple plots inside this same cell. Did you get it? So if I want to plot another one now, I'll just do enter like this. What's the formatting for the other one? I will start doing all the formatting. S ticks and so, because if I didn't do formatting, the next one that is going to plot for me is going to use this 90% rotation too. Did you get the idea? So if I want to plot on that one now, I will just copy this now. Let me say I copy, paste. Are you there? So I can reformat for the next one that I'm plotting. Did you get the idea? I can reformat, say this one, let me change this one to like 40 degree. I can change the title too. So this is what it is going to use for the plot that is coming after it. If I run. Why am I having just one? This crop, okay. plt.xtics, plt.subtitle, plt.xtics rotation, okay. Let me see. Oh, this is Seaborn something. Seaborn wouldn't allow me to do multiple plots in one cell. Yeah, but if it was to be matplotlib directly, I'll be able to do multiple, like just write all the code together, then it will plot all of them for me. But I still see Seaborn. Seaborn is replacing themselves, like it's replacing the former one with. Are we there? Oh, okay. So that's not. It did not ignore it. Where? That will create a multiple. Where? No, it's import. You are importing something. So you go and paste it under the import. Are we there? So it is not only for this one that we ignore. You are not going to see any warning on your notebook again. If there's any warning for anything, it shouldn't pop up. Except if it's now a error. Call error. Are we there? So let's set our X label now. If I set my X label, what do I set my X label to be? I will say amount, right? Are we good? Then I'll set Y label. I think density is okay for Y label. So let's just leave it like that. X label no deal. Set X label for Seaborn. Okay. Dot set. Okay, we'll still call another dot set again. Okay. It should be inside this set, right? So I can have x label equal to, let me say, amount here. Enter. Yes. Are we good? It's still inside the dot set. Are we here? Let me even see the amount of things inside that dot set. This one not even open. Shall we wait a little in it? Okay, good. Alright, are we good? Then let's go to the next plot. If I copy this one, Ctrl C, if I paste it down, I'll just change this one to what? What's the next one? Phosphorus. Phosphorus. Are we there? Then I'll change this one to let me make it capital. Phosphorus. If I enter, I think it should plot. It's plotting on the same thing. Okay, this is now 1, right? Enter. Are we there? Huh? Okay. If I copy again, what's the next one? Potassium. Temperature. Potassium. Potassium temperature. This is 1,2, right? Now this is 1,0. The temperature is almost uniformly distributed. I'll make this one degree. The temperature, I'll make this degree. And I'm thinking about how people. So if I copy this, Ctrl C, if I paste it, so what's the next one I want to plot? Humidity, pH, rainfall. Humidity, pH, rainfall. Change this to humidity. Humidity. pH. pH. Rainfall. Rainfall. Enter. Okay, so this is 1,0. This should be 1,1, 1,2. Now this is to be 2,0. Nice. Nice. I just copied and paste. Then we just change the X. The X that is coming here is nitrogen. The X that is coming here is phosphorus. Yeah, then we now add a set title. Yeah, on each of them. So we set their title, then we set the label. The label is this one. X label. We can as well change this one. This one is going to be Y label. But it's just fine. That's why we left it like that. Alright. Please, can we be on par with this?
Okay, the label, the added label.
Yeah. This is X label. I just want the temperature because I know that the temperature will be in degree. Oh, this one is cannot be in degree. Humidity cannot be in degree. So let me just make it amount. I don't know the distance for humidity, so I just make it amount. pH scale, I'll make it amount. I'll change this one to amount. Are we good? Yeah, this is beginning to look nice. So this is what I'm doing. The first part here, I created some plots, which are just the structure. You get it, the whole like this. This one is called, in case you want to Google, for people like Josephine, that I know will Google a lot after this class. The whole thing is called a figure. All of them, as long as you are creating them in one. That single one that we create before is a figure. It's just that it's just one that's on the figure. Did you get the idea? So you can create several figures like that. Together, they are figures. Are we there? Now, inside a figure can contain axes. Now, inside a figure, each one of these ones now are axes. Like this. So, in case you are searching, you can now say how to create a figure, how to create multiple axes inside the figure, so that you'll get a return, more fine-tuned return. Yes, you can create more than one figure. Yeah. No, not inside here again. You can go to another cell, create another figure there. Yeah. Are we there? But for one listing, one figure, what do you want to do?
Why are we plotting temperatures? If we are talking across, why are we plotting these temperatures?
Yeah, they are our predictor variables. We want to understand their distribution. Okay. Imagine that now I know what the distribution of my training data set looks like. I know that majorly the temperature that I trained on is between 20 to 30 degrees Celsius. Are we there? Now, if I am to use this model in China or in Canada, it's going to falter. Because temperature around there, is there a way we can get temperature of 20, 30 in Canada? I don't know. But it's going to, you get the idea. So I will now be looking at, I will have an explanation for why my model is not working appropriately. Did you get the idea? Because when I plot the distribution, I will see that what they are looking at out for. And if I want to suggest that people use this model, I will tell them to use the model where. Did you get the idea?
Go back. Temperature. We just change the temperature degree.
Yeah. So looking at this, I might not be able to explain what is actually going on. What they stand for though. But if something is wrong, and they now give you the testing data, and look, see people, this is, and look at the model's prediction. You can now replot again and compare it to what you trained. You see the shifts. You get the idea? I trained from 0 to, my temperature is from 0 to 40. That's my training temperature. But what people have been testing it on is from 100 to, because if we test on like 0 to 20, it's still going to be fine. Because it covers 0 to 20. But imagine that it's now 70 to 200. It's not that the model will not work, but the performance on it is going to be hard. So these are axes. Axes. Are we there? I think that's what this line here is doing. This first line. It creates a figure, creates axis for us. This one is containing multiple axes now. This is what I am using to control the axis. This is my number of axes. I'm saying create 3 rows, 1, 2, 3. Then create 3 columns, 1, 2, 3. So if we look at what we have 3 rows, 1, 2, 3. Then 3 columns, 1, 2, 3. If I had said like 2, 1, it would have gone 2 rows, then just 1 column. So it would just be 1, 2.
So what if you have a large data set?
If you have a large data set, yeah?
You go to check the number of.
Yes. Like for example, you have 100 data sets now. You know you can do say 5, 20. But that would be too small. It will be too, because we are going to have 20 columns now, it will be too compact. So we can do 20,5 or 25,4 or even 50,2 so that we have 2 Are we good to go? Good to go. And funny thing is, even if for this particular use case, even if your this thing is small, you shouldn't worry so much about it. So we can have 4, 5, like column. It's for us to see the pattern, what it is looking at, what it's looking like. Yeah, like even if this is smaller than this, I will get the information I need from it. Did you get the I'll get the information because I'm not really interested in each of the. It's now when those plots that are interested in each value.
That's the part of one movie.
Yes. It's not compulsory. Okay, to get this one. Yeah, no, what me I do sometimes is I do each of these steps different as a different notebook. Yes. I do one, I will do introductory notebook. Introduce the project, what data set I'm using, and all those kind of introductory notebook. Then the second one, I will now do ED. Notebook. It's still inside the same project. You get there. So those first start and just the one notebook. So it's now going to be expensive. When my data sets, the methodology I plan to use, I'll put that like that. Then the second one, EG. And I use that when the data set is large, when I want to do comprehensive work. To get the idea, so I'll do that. Then the next one, I'll do pre-processing differently, model in different way. You get the idea.
Instead of one long
notebook, yeah. Let me show you an instance of that. This is an instance. Did you see it? I did data gathering because I'm the one that sourced for my data myself. Yeah, for this project, I sourced for it myself. I did, I collected from this thing, then I used ChatGPT to script like that. So I have data gathering. See? But I joined both introduction. I introduced the project with data gathering, see, project overview. I introduced together with data collection, see. Then I was introducing the project. This is all data gathering now. You see? This one completes. Then you look at data pre-processing. You see? This one is extensive. Pre-process the data. See? Then, and you just imagine that they are one notebook. So I now started, I've not even started analysis, that's just pre-processing. So this is now the analysis now. So I did a hypothesis, what I want to verify. Importing the data set. So this level of education, say, let me even see why I said that if I look at my project I will see codes. I will see codes. So normal. I'm working on a project, I'll just go and copy all this one, just go and paste somewhere, adjust the attributes. So I wouldn't need to go, just pick. Now, if I want to do now, see, I've created subplots already. Number of rows, number of columns, fixed size. See, the code is already here. Now, look at the loop that I'm telling you about. I used for loop here. I didn't do it 1-1. You see, I used for loop around there. Now, this is me now adjusting. See, set title, set X label, set Y label, set tick parameter, adjust spacing. See that all those codes is here, the same code that I've been fixing. So, see, this looks nice. Okay. Number of fatality by regions, major occupations, average number of incidents per occupation, average number of security incidences, number of fatalities per occupation. Okay. So this is because this is a very wide, very large data set and code. That's why it has multiple notebooks. So it is acceptable for you to do. Okay, are we at the same page now?
Yes.
Alright. So we are done with univariate now. The next part of the analysis is going to be multivariate. I remember when we were explaining the last part, I told you that the goal of this one is to compare with our target variable, right? How do each of them affect our target variable? Remember? So we now look at each one of them together with our target variable. I can be scatter plot because normally this can it be scatter plot? Can it be scatter plot? We are now doing numerical with categorical. You know, scatter plot is majorly numerical. So numerical, categorical. What do you use for that? Yeah? It's going to be this, not this plot again. Cat plot. Yeah. Cat plots. You know, real plots if they are numerical. Right? Cat plots. So let's do that. So let's create a subheadings now. Let's create a subheading. And funny enough is this section we can still make it like this too. Did you get the idea? Yeah, we can make it like this too. So let's do that. I'll just say predictors. I can make this one, I can use this heading. 1, 2, 3. I can say predictors with target variable. Right? You understand? Or we can say relationship. Are we good? Okay. Relationship between predictors and target variable. Nice. Are we good? So let's just copy this code. Life's simple. Copy this and paste it here. Are we there? Life's straightforward. So we can now go. Now we are mixing two now. Before we have been plotting just 1, 1, 1. Now we want to plot this one with our label. This one with our label. Are we there? So let's go. Let's say, so this one is going to be cat plot now, right? So what's going to be my x-axis? What's going to be my x-axis? My x-axis, what's going to be my x-axis? My x-axis is going to be the feature, numerical value. My y-axis is going to be count of my category. Are we there? So it's going to be the label. Are we close? You get the idea? So it's going to be at this point of this nitrogen, how many listings we have? At this point of this nitrogen, how many listings we have? Are we there? So if I go cat plot, I will now say my x is what? Nitrogen, right? What my y be like? Y equal to what? Y equal to df, right? I'll do space. What do I label, right? Let me see how this first. Did it work? Nah, it didn't work. X is nitrogen, Y is this. So why is this not working? So why is this not working? Why is this not working? Cat plot. Okay, let me see if it is potassium. If it's because we are using, is potassium double T or double S? Eh? Double S. I'm sure it's double S. Okay, so what's making this one not to show? So let me check documentation. Let me check documentation. Seaborn gallery cat plots. I'm looking for cat plots. Okay, I'm seeing cat plots. So cat plots here we have data, okay, XY. Data XY. Okay, let me see. So this should be nitrogen, phosphorus, and I'll just add data here. I'm commenting. So let me see. Data equal to df. They're passing my axis. Still didn't work. So what's going on? Okay. Let me remove all these ones first. Now I see. Let me see. Da 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 da. It actually does work here. Potassium. Okay, so let me add label here. Let me see. I'm coming. Okay. Well, why is it the axis not working? X 0. I put it there now. Voila, good day. Why? What's going on? Da, 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 da. So I don't know what's going on. I don't know what's going on. Okay. I don't know what's going on. Let me make this one axis 1. Axis 1. Sharif, how do we fix this problem for you yesterday? Last class. I don't know this happened to you last class. So how do we fix it? Real plot, let me see. Scatter plots. Oh. Those things would not stay inside. They would not stay inside the charts. Isn't that ironical? Are we here? The problem is those ones are not staying inside an axis. Seaborn stuff, I guess. So we need to use each kind of plots themselves. So I use scatter plots and it actually work. So let me go and check one that I can use. Gallery here. Numerical and categorical. I think list plots, scatter plot, box plots, no, strip plots, joint grid, pair cross distribution, bar plot, no, can't use this ones. Parallel plot, line plots. If I use line plot, let me see. Line plots. Oh no, this shouldn't pass the message. So I think I'll just go 1-1 then. I'll go 1-1 then. But I'll look for a way to do multiple for more projects. I'll look for a way to. So I'll just not use axis at all. Remove these ones. Then bring in something like this. Bring in something like this. Have it here. Yes. Okay, so I'll do, what's the title of this one? Nitrogen with label, right? So this is not going to be count plot again, right? So we can make, what can we make this one has? I think we can have scatter plot. So I have my X as nitrogen, right? Then I'll have my Y equal to what? Label, right? Then plots. Okay, I have a syntax error. Okay, so what's the error this time around? Could not interpret value nitrogen for parameter X. Could not interpret value nitrogen. Okay, so I think it's expecting the full this df this. Okay, then remove this one, then run it. So what's going on now? Nitrogen. Is it not that not how nitrogen is spelled? Is it capital? Oh, yeah, I think that's the mistake there. Okay, so we have this. We have this. Are we here? So from this chart, mhm, mhm, mhm. It is easy to interpret. Most of the crops require maximum of 40. 1, 2, okay, to 140. So 1 highest is cotton. Are we there? Are we here? If I want to interpret this now, I will interpret that most of the crops actually require between 0 to 40% of nitrogen. Can you see that from the chart? Yes, most of the crops require between 0 to 40%, 0 to 40% nitrogen. Are we good? Huh? Oh, if I want to make this with what we know, I can swap them. So put it here so that my nitrogen is going to be my X, and this is going to be, the label is going to be X and Y. Which one is much more preferable? I think the former one. You prefer this one?
Okay, this is just like.
Because, yeah, this is telling us that every crop that is classified as rice has nitrogen between 60 to 100 for rice. Are we here? Now, every crop that is classified as maize has nitrogen between, the same thing with rice. Are we there? Now, for, let me see, 60, 100. Is there any other crop that has between 60 and 100? 1, 2, 3.
Second to the last.
Yeah, this one. 1, 2, 3. Then some of these ones enter 2. Right? Some of these enter 2. Are they being this one didn't enter? Like this one was off. Are we there? Then I would say nitrogen is easy to identify. How would I say it? These two crops are easy to identify. Did you get the idea? From nitrogen alone, we can pick both of them out. Did you get the idea? The model is going to be able to figure, even as it stands now like this, the model would perform very well. It will perform very well on any crop that is rice, any crop that is maize. Are we there? Rice, maize, probably what? Jute. You know why? Because they are distinctive even with nitrogen alone. I plotted only nitrogen and I can see them standing out. Now the one that is going to be most easily differentiable is this one. Nobody is actually sharing with him. It's just very few that they are sharing with him. Are you there? Did you get the idea? Now the most difficult ones to identify are going to be this. Nitrogen cannot differentiate them. You see them, they have the same requirements for nitrogen. Are we good? You see how you translate this kind of, this is the crops now. These are my crops. Are we there? And these are the nitrogen requirements. Are we good? Now for all these ones now, this is kidney beans now. It's requiring from 0 to 40. Pigeon beans, all that were classified as pigeon beans has nitrogen between 0 and 42. This is each sample. Each one of those dots are samples. Did you get the idea? Each one of those drops are crops. This one dot here is a crop. This is a crop with 0 nitrogen here, actually being classified as a kidney beans. This another crop here with 0 nitrogen, actually being classified as a kidney beans. Did you get the idea? So if I now tell you that this particular crop has 0 nitrogen, where are you going to put it? Did you get the idea? It's a lot more difficult. Are we good? But if I tell you that a crop has nitrogen of 80, it can only be one of 3 crops. 80, let me see, 80. Okay, this one's to enter. Right? Okay. What about 70? Nitrogen of 70, this is 70. Only 3 of them. So if you see nitrogen of 70, you know that it can only be one of 3 crops. Are we good? Can I use bar plots? Let me see. If I change this one to bar plots, can I use this? Yeah, I think this is a lot lovelier. This is a lot lovelier. This is a lot lovelier. Eh? Yeah. So. Very good. Now, if I want to use this, I actually know that this is actually one very good feature. It's actually one very good feature. It's a very good feature. You know why? You will know a very good feature if it actually distinguishes all those items. If it separates them, you will know that this is this. But imagine that I plot this now, and all of them are the same. Did you get the idea? I might not conclude at that point that it is not useful, but I know that the usefulness is quite limited. Because independently, but this one, independently, if I use only this one as it stands now to do my modeling, I will get to some level of accuracy. It's not going to be accurate because in this regard now, see, anything above 80, it just knows that it cannot be any of all this. Anything above 80, you should know that it should either be this, or this. Did you get the idea? And this is actually why I would prefer the other chart, that the other chart is showing me the minimum and the maximum. This is not showing me the minimum. This starts from 0, it's just showing me the maximum. You see the difference between this one and the first chart. That first chart starts from where the thing starts. Like rice is between 60 to 80. Anything 100, 150, you know that it cannot be rice again. You get the idea. So this feature is actually a very useful. It's actually a very useful one. Okay, so I'll plot all of them. Let me write a little comment. This feature individually will contribute much to the model performance as it distinguishes the different crops in the data sets. Are we there? Alright, so let me pick another one. Relationship between the target and the predictor. So I use nitrogen with label. So let me pick another one. Control C. Go down. So I'll pick potassium. Potassium with label. Potassium with label, let's see. Let me see the other one first, scatter. These two crops kind of similar. Grapes and apple. Grapes and apple. Grapes and apple. Apple with grapes. Grapes and apple. Wow. Grapes and apples. Grapes and apples. Are we here? I'll leave this one. If we look at this one, grapes and apple, they actually require very high potassium level. I'm going to plant grapes and apple. It is very, very high potassium. While every other one is between 0 to 100. Yes, at least this one, this feature alone would help identify grape and apple a lot. It will still identify this one to potassium. Grape, apple, potassium. Grape, apple, potassium. This feature has made it easy to identify those things. So let's see. The only confusing ones are these ones. All right. Just see, I don't like this chart. This one. It's actually finer. It's actually finer. It's easier to understand when you look at it, but it's not passing the message I want. Yes, I'm not getting the point that I want. If you want to actually make a point from this chart, you are not actually, so you are telling me from 0 to, now this is actually telling me from 0 to 80 for X, which is actually wrong. That's why sometimes they say visuals can lie. Even analysis can lie. If you present this one to somebody now, what this thing, without you explaining, what it is telling the person now is that rice will grow in under 0 to 80 nitrogen. That is what this chart will tell the person. Are we there? But while in the ideal, if I use swarm plots, rice maize, okay. Now if I use swarm plot now, swarm plot, the ideal is telling me that it's only between 60 to 100. Yes, it's giving me 0 to 80. But why? Why is the chart different? Scatter, let me use scatter plots. Nitrogen. You see? To some degree. I think I prefer this one. Because this one is giving me the minimum and the maximum. The other one is just giving me the maximum. Are we here? Yeah. I'll go with this. Okay, so continue this way. I think I'll stop here. The others are still the same way too. We just relate all of them together like that. Are we together? Eh? Which one? Yeah, there's swarm plots. There's scatter plots. So this one is scatter plot. The other one that I used that time is bar plot. Yeah. That one too is used with its own this thing too. Are we there? Now, one thing you cannot do again is, are you there? If you are now trying to look for example now, if I want to drop, yes. If I want to drop features now, why I wouldn't do analysis for this one is I don't have any business dropping. Because they are just 10 features. But when they are 20, they are 30, and you are looking for features to eliminate, make your models faster. I'll now look at this. See this one. All of them have the same, almost the same thing for nitrogen and potassium. If they pass the same information, you look at the information they are passing, and they are the same. Are we there? So this is what I'm talking about. See, do this with themselves. Let me compare with themselves now. Let me compare now. I'll now use scatter plots, right? Instead of label now, I will do nitrogen and watch what happens. Okay. Potassium, this is potassium. We have higher potassium here. We have nitrogen here. Okay. Is it increasing as? It's increasing, no. Now, this is what I'm talking about. See this one. They are actually two very distinct features. Did you get the idea? How do I know that there are two different distinct features now is that it is not increasing as one is increasing, it is not reducing as one is reducing. Did you get the idea? Look at their chart. There's no correlation between both of them. If I had distributed this thing and it goes this way, it goes pa like this, then this thing now, instead of going this flat, it goes probably like this. Did you get the idea? Or it goes this way, even if it's not that, just something like this. Did you get it? Then you have a clear distinction that as it is increasing, or it goes like this. Did you get it? You know that as one is increasing, the other is reducing. That is correlation between both of them. I can drop one of the two features. Did you get the idea? They are telling the model the same thing. Just the way me and you have been looking at it now. You know, I can't look at these two now and tell us and actually predict what the crop will be. But if yes. But imagine that I plot nitrogen, it looks like this. And I plot potassium, it looks something similar too. Did you get it? I can be able to tell that nitrogen, rice under nitrogen, is almost similar to rice under potassium. Then they are telling the model the same thing. Because the model doesn't know that this is nitrogen, this is, what the model is looking at is numbers. And if you have a column which numbers are telling the model almost the same thing, then what is the essence of that fig there? Just let it fly. Did you get the idea? So for this one, I'm not looking at reducing any feature now. You get the idea. So we are just going to let it like that. But should I want to reduce feature, that's what I will do. Probably if we have 20 features, 30 features, and I'm looking at it that it's too much to be using to predict, then I will just look at the most important ones. These ones and these ones are related. Let this one go. This one and this one are correlated. Let this one go. Are we there? Yeah? The last one. The first one. Are we there? So, next we are going to do data preprocessing and we are going to move the data for so that we know.
Well, I can just, instead of, like, we were talking about the asking the project, it's like separating, putting it in categories.
Yeah.
So I can just, like, if I want to do a single, like, I don't have to much.
Yeah.
I can just decide to take the first page, like, do like a lot in general. Not like I'm presenting that from just like a raw
Okay.
from yes, like,
Yeah.
and then take the rest of it instead of just doing the raw.
Well, I think that's what you end up doing most of the time.
Yes, it's not really-
It's not defined. That's what you do most. That's what you do most. That's what you do most of the time. But doing majorly, I prefer to be guided. Like, for example, now, the way I did these two, the way I did these two analysis now, I will get something to analyze again inside. Did you get the idea? I saw it, but I just don't want to prolong the class. I don't want to prolong the class. Apple and grape. Apple and grape are having almost similar requirements. Apple grapes. No, I think apple and grapes particularly. Because what it will lead me to is, it will lead me to if I continue that pattern, it will lead me to, I can be able to tell which fruits from just seeing their nitrogen and this, I will be able to tell it. That's what I want to look at. And if that is actually possible, then there's no need for machine learning. You get the idea. So if I know that grape and this thing have the same requirement for potassium, I look at the nitrogen, and nitrogen is different. Totally different from both of them. I know that nitrogen already separates the both of them. You get the idea. I know that this is, so if I hear 70, I already know that this is either apple or grape. You get the idea. So what is it that is separating them? I will now check their nitrogen again. Where did it fall? I will know which one is among both. So if I want to know analysis further, I will get the analysis. You see how the, now, for example, nitrogen separates, nitrogen is actually not as useful as for individual persons. For individual person, that nitrogen, this potassium is way, you see, separates these two totally. Like, you can tell these two totally, you just using their potassium. Potassium level, those two foods, don't tell them directly. You can see them now, nothing is competing with them. They have very high potassium requirements. So the first thing I will be telling you that what is the potassium requirement? I will know the fruits. Just tell me the potassium. You tell me the potassium. It is less than 175. I know that it can never be grape or apple. Because from what my record is saying, grape and apple is 175 above. So I know that it can never be grape or apple. So if it is between 100 and 75, I know the fruits. I know the crop directly. It's going to be chickpea. 175 is chickpea. Nothing is competing with it too. So So potassium has separated 3 crops out of the 20 that we need. Are we there? Now potassium actually puts all these ones together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10. Then I can now bundle this 10 and look at them if nitrogen separates them. Eh? Exactly. This is actually doing the predictions already. Eh? So if it is possible that all of them are easily distinguishable by that parameter, then you won't need machine learning. Did you get the idea? So this is one importance of EDA. Your directors want to know machine learning necessary. Just imagine that you now going to spend hundreds of thousands of dollars to build a machine learning model that if S statement. Because what I would have done is I can create a system that will just use if S. If potassium is between this range, it is apple or green. If potassium is this and that, that will not take somebody more than 20 minutes to code. You get the idea. If you are hosting a machine learning model, you train a model on people's budget. You host a model and you continue maintaining that model on something that you test. So you get the idea. So that's one area. So it's not as if it's a structured kind of thing. You go with the way with what you are seeing and just try to derive the inspiration. What the data set saying? What is the data set saying? You get the idea. Sometimes it's very useful to modeling. Sometimes it is not. It's you understanding what the model is saying. But as you go along, document what you are finding out. I'll document that potassium actually separates grape and apple. So when the potassium is this level, you can be certain that it's either grape or apple. The nitrogen separates them. Then we check. Nitrogen is separated. Then there's further one. So I've not gotten clarity on any of the I look at both the two other lists. I think which one can be separated. But you know now, according to that, I identify chicken pack. Did you get the idea? I can identify chicken pack. Because chicken pack, nitrogen separates chicken pack. Completely, I said nitrogen, potassium separates this. So that one is now authority. Without any system, you can identify that one comfortably. You didn't get the idea, yeah. So that's that about that. So I will not dig in deeper into this EDA. If not, we are going to sleep in. We are going to sleep in EDA for this project. I'm going to sleep. So next class, I'll be going into pre-processing because I've just found out that the model, this is needing so much pre-processing. Yeah. So pre-processing and yeah, plug the minimum. Tell me what you find out. On the minimum. Tell me what you find out. You can plug them against themselves too. See? But that wouldn't be necessary for this data set. Power BI, yes. Power BI can help you. Just to get your point well. You can use Power BI too, but data science, we use notebooks.
No, like I'm just saying, like, it's not like you want to just do it.
Yeah, you see like Power BI is easier to use for data. Yeah, you can use Power BI too. So that is why you found Power BI in the class. But even after using Power BI, you still have to plot the points inside here. Yeah. Are we good? Even the bank application that I created, I've almost been able to figure out like just able to the bank project. It was just one thing I refused to separate. That's why it just goes to the machine learning model. One What was that thing said? Like, I can't remember what happened then. But because I've noted already that transactions within so and so amount, most times they are fraudulent, but there are some that are not fraudulent. But when you now add a type of description to it that says they are going on holiday, those ones now, everything now becomes fraudulent or non-fraudulent. But there are some miscreants that was unable to separate some fraudulent transactions that my condition was unable to, was unable to capture. Just very few. So I have to use my chain. But if I can bring out a condition that captures all of them, that when this particular one is between this particular one is between this, and there's no one, all the fraudulent transactions fall into that class, there's no need for machine learning again.
I think that is common too. Is it because it's categorical?
Categorical variables? No, it's not though. It is not common though. It is not all the time that you can find things that will separate it. Yeah, it's because the listing is separated. Because the real life scenarios, most real life cases, you can't separate them. But if you can separate them, then there's no need of machine. There's no need for machine learning. Again, that's just the idea of it. If you can separate them by just analysis, looking at them, this one, this one, this one, this one. Yeah. Okay. I think we are 1 o'clock. So let's go back to our hosting of our project. 12:59, yeah. That's still 1 o'clock now. So let's go back to hosting of our projects. Are we good? Huh? So where did we stop with that hosting program? I'm not even sure that we can activate our environment. I'm not sure that we can activate our environment. Yes, now we started. In fact, we have created the server. We have already created our website already. Are we there? What's the title? It is still the same project now. Okay, so we created a project for it. Are we there? We created a project, right? For it. Then we created a virtual environment inside that project. Are we there? After we created the virtual environment inside the project, then we activated the virtual environment. After activating the virtual environment, you install what you need inside. So we have installed Django inside that virtual environment, right? After that one now, then you create the Django project. After creating the Django project, you create the Django app. After creating the Django app, then you start the server. Are we there? So what are the steps again? What are the steps again? 1. Create the project, right? 2. Create VE, virtual environment. 3. Activate VE. 4. Install Django. 5. Create project, Django project, yeah? 6. Create. I'm sure that me myself I would have forgotten all the steps. Alright, so I'll rush over this once again quickly. But it's not as if I'll teach you, I'll just create new one. I have my application already. CMD CD desktop. So make directory, I'll create a project let me say test project. All right. So I've created a new project directory. So I'll cd into it, test project. I cd into it. Are we there? I'm in my project directory now. I want to create a virtual environment inside my project now. So I am not following this one.
No, I want to say people have done it. They're just
Okay.
like
Yeah. So I will now create a virtual environment inside. So how do I create a virtual environment? I've forgotten. Virtual environment. I think it has to be Python M, VM, right? Then virtual environment inside. Yes, it's creating. Grassy. It's creating. It's not done. It's not done, 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 it's not done. Yes, it's done now. So if I check there, I should see a environment folder inside. Then I will activate this environment. You know the use of environment is creating like a microsystem for me inside that I have access. If I use this my particular environment, I'm going to be having access to everything under my system. So if you are not deploying to the cloud, are you planning on installing everything on your system on your cloud? No. So I just need only the things that I need. That's why I created a small environment for myself. Did you get the idea? So let me activate this environment now. Environment / scripts, right? / activate. Enter. You didn't find it. Environment / scripts. Yes. It is activated already. You see something, you see an environment folder by the side. Are we good? So I am in the environment now. I am in the environment. Are we cool? 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 Alright. So next thing I would install what I want to install, right? Pip install Django, enter. Yeah, I have Django now. Then I'll create a Django project, right? So I'll say Django / Django admin, right? Create or start project. Start project. I don't know how that goes. Is it create project or start project? Create, let me use that one first. Create project. Start project, right? Django admin. Okay, start project. Are we good? Then the name of the project, let me say new. Then I would have a dot, right? To achieve this folder structure that I want. Django admin is not defined. Admin is N. Django. Okay, admin. Okay. Why this one they wrong? Okay, it's complete with the name of an existing Python module. I cannot create a Python new, so I'll just name it name 2, new 2. Alright, this created, right? Next thing, I will create a Python app, right? So that will now be manage.py start app. Let me say new app. Enter. You say? All right. So I'll now go. What next? What next? What next? What next? What next? What next? Python manage.py start run server. If I run it, I should have a link. So if I copy this link, my program is already up. Welcome, Django. Thanks this work. Are we there? So if I host that application, if I take it to the cloud and I host it, they would be able to see this page. Everybody that logs in will be able to see this page. Are we here? So what is the next thing that I want to define now? Let's go. Oh, sorry, this is not where I'm going to. Are we there? Where the former one? Okay, I want to break this. Control C, I break it now, right? Now I want to deactivate. This is not the project that I'm working on. I will go to the other project now because we have already created all this now. I will deactivate. Just write deactivate. Enter to deactivate it. Are we there? Now, where starts my project? The project that I want to activate now, it is on my desktop. I will go into that project folder. Did you get the idea? So it is, let me switch to that place. What's the project folder? This is the project that I'm working on. Crop prediction, this one. Are we there? This is my project. Are we there? I'm using the same project folder for both my notebook and my server. Are we here? So I'll copy this part. That's on my desktop, crop prediction system. So let's go cd crop prediction underscore system. Enter. Are we here? I'm inside now. Are we good? So can all of us activate our project now? Can we activate our project? I'm inside my project folder now. So the command, you know the command already, right? Environment slash scripts slash activates. I'm inside my project folder now. How many of us have Visual Studio Code? You must be in your environment. No, you shouldn't go into the environment. How to see the screen? So next thing that we are going to be looking at creating is one important thing of any application is your URL. You remember that we have one URL already. That main URL that we copy and paste. But that's taking us to one generic space, right? Now we need for every model that we create, we need a URL, a specific URL for it. Did you get the idea that you know that when somebody visits this place, it is going straight to where you host your model? Are we there? So we are going to create that URL. Now what's a URL? A URL just takes in request and gives out response. But it is not him that is taking, it is not the URL that is taking the request and response. The URL is just a name for that. Now when you go there, what do you need? Are we there? That's the work of the view. Did you get the idea? A URL is more like, I would say a view can be a house. Houses. So I have a house now. I have another house now. I have another house. Are we there? Now these houses contain different things. Let's say this one is restaurant. This one is school. This one is university. Are we there? Now this URL is what I'm going to be using to point to them. Did you get that? It's not as if the URL is doing anything. The URL is just an intermediary. Go to this place. Go to this place. Go to this place. But I would need these views, right? Now these views are the ones that take the response that is coming. Don't forget that aside just this, my URL will still collect requests. It will collect the information from the person. Did you get it? To collect requests. So now there are two types of requests. There are, is it two types? There are like 4, 5, 6 types. But we are not going to concern about the other ones. We are going to be concerning ourselves about get request and post request. Get request and post request. Are we good? Now what's the difference between the two types of requests now? The difference is this. When you use get request is not expecting any data from you. And that's what you see from your traditional browser. When you go to Google, http www.google.com, that's a get request. www.unicorntechhub.com, that's a get request. You are not passing in any extra parameters. Are we there? www.google.com/this is still a get request. It is not expecting anything from you. Are we there? Now, we are now going to need post request. If we just don't want to go to the address, we want to send additional information. Are you there with me? For an example, I want to go to a website that predicts something. Did you get the idea? Most likely the website will request some information from me, like age, name, and so. If I want to send that information, the only thing I will have is post request. Because they would only have implemented post request. The post request allows the user to send in additional detail. Are we good? Are we great? I'm good tired. Alright, so let's see. Now if you look at my data structure, right? If you look at my data, I don't know if I can make this one is not zooming. Let me see view. Appearance. Zoom, yeah. Zoom in. Let me try again. View. Appearance. I think I saw it. I just didn't cram it in. Let me see. Zoom in. Control plus equal to control. Yeah, I think this should be fine. Are we there? Now look at the program structure that I have here. If you look at your data, you see that this is our app, right? Isn't this when we created our app? This is what we called it, crop API. Now this is our environment, right? Eh? Remember I put this data set. This one is coming from my former project. It is not by now. I have this project inside. Remember, this is Django project. When I created Django project, this was what came out. Right? So you must be able to identify all those folders. You can create them with different names though, but you should be able to identify which one is which because you need them. Are we there? So inside my project folder now, inside my project folder, I should have something called URLs. You see? Are we there? Inside my project folder, you should have something called URLs. Now, if I see this URL, if I go into this file, the URL file now, you see? This is where they define all the parts. This is where we are going to define all the parts. It's more like routing. If somebody said this, send it to this place. Somebody said this, send it. So this is my route now. This is my route. And this is where it is going to route it to. This is the URL, sorry. Are we there? And this is, so my only work there is to just edit this file, add more to it. Did you get it? I want to create new routes now. I'll just do something like this. I'll copy this whole file like this. Copy it. Are we there? Control C, then paste.
Just like trying to create
Hyper.
like trying to create hyperlinks.
Yeah. Hyperlinks.
No, like the idea of HTML, like
Yeah. No.
like when we're trying to create that
Href.
yeah.
This is quite different though.
No, I'm just like creating the idea.
Yeah, this one has this one. You know HTML. You already when you are writing HTML, you want to host. They already have a server like where you host that thing. What HTML is doing? HTML is just writing from one page to one. Okay. That is the direction. Yeah, something similar. Yeah. Are we here? So now, my default is always going to be there. You know what my default will be? That HTTP, the former link that they gave us, is always going to be there. That's my local server's IP, the URL. Do you get it? Even if I'm not using this computer, if I host this project in the cloud, that cloud will have its own. Did you get it? Like for example, www.vinicomhub.com. That is what this one is representing. This one that I have here. Did you get it? Just that one has gotten a domain name already. This one has no domain name. Whatever domain name I buy now is going to represent this. Are you there? So now the program will automatically identify your this. Don't worry because we are hosting it there. Now we now need more. It is now the slash that we are now going to be defining. Slash this, slash this, slash this. Do we get it at all? So, for example, for this project, now I want to do predict, right? I want somebody to do slash predict to go to where my model is. Are we there? So I will define slash predict there. Then where do I want it to go to? I don't know because I have not defined anywhere. Remember that I said we need URL and we need a view. Are we there? So now I don't have a view. So for the meantime, I will leave this one like this. I will go and create a view first, where I will direct this one to. Did you get the idea? I need how would I explain this? Always have it at the back of your mind that you need a URL and you need a view. When you go to www.google.com, Google already has a view. When the request comes back, it will go to redirect to that view. It is whatever the program in the view says that is going to return to the. Are we there? Now, as we are doing our own now, we have a URL now, predict, right? But we don't have a view where we are going to direct it to. What should it do? Did you get the idea? When somebody comes here, what should it do? We don't have it yet. Are we good? Yeah. So we can now define that here. So now, you know why this URLs is inside our project folder? Do you know why the URLs is inside our project folder? All the URLs that is going to manage all our app is going to be here. Did you get? You know we can have multiple apps in this project. We can have like Vinicom or Vinicom Tech or Vinicom this inside the same project, right? All the URLs that will manage all of them can be inside, will be inside this project folder. Are you there? Then the view are now going to be inside individual apps. Did you get the idea? Somebody wants to go to Vinicom Tech Hub. We can have the URL here, Vinicom Tech Hub. Vinicom Solution, we have the URL here. We are just going to be redirecting them to their different respective apps, to the views there. Now, if you go and check inside the app itself, we are going to see a file there, views. Did you see? We have seen a file there, views, so click on it. Are we good? Now, we want to create a new view now. See, this Django is actually not very hard. It's more like there's just step and step and step and step that you need to follow structurally, like in their order. So, how do you create a view? The easiest way is not to use Django itself. You can create view with Django. You can create a view with Django itself. Are we there? The easiest way to use Django REST framework. Are we REST framework? Are we good? Now, this is, let me relate it. This is the instance of Matplotlib and Seaborn. Did you get the idea? Matplotlib is, you get the idea. Well, sometimes you don't need all those. Imagine these few lines of code that I've written that I need for my data science project, and you are not giving me a documentation. If I show you Matplotlib documentation, again, because it contains a lot similar in this scenario too. Did you get the idea? Well, we just want to create APIs with Django. Why not give me something, encapsulate this thing for me, and then use what I will use and get back? Are we there? So we'll go and install again. Django REST framework. Please, let's install that. Please write that one under your installation. Anytime I say we install something, write under your installation. That step where we install. You know, you can do it even at the beginning of your project. I just don't want to confuse us. That's why I didn't do it in the first stage. Do you get it? Eh? Django like this. Django underscore REST. I don't know if the REST framework, I don't know if there is this thing between it. Just Google install Django REST framework. So write it under the installations. That's create project, create virtual environment, activate virtual environment, install Django REST framework. Why did you write that? You write it. You have installed Django before on step number 4. Why not install Django REST framework at number 5? We are still going to be installing some other things. So just install that. In fact, I think number 4 together, just add it so that you know that your installations are number 4. So let me see if you know how to install that now. Eh? Pip install Django REST framework.
Okay, now I know.
Yes. Eh? In the command from command, eh? From command from now. You are installing in this particular environment now.
Okay.
You are already on the environment now, right? Just to click install Django REST framework. Just the way you install Django. Click install. Please install. I didn't know the attached to the Django REST framework.
At least one word.
Eh?
One word. Django REST framework.
You saw it somewhere.
Yes.
Yes. Django REST framework, one word. Django REST framework, one word. Views. Okay. HTTP response. JSON response. Ah, I love this. HTTP, Django.http. Then why do I need to install Django REST framework if I can just use yeah? Stop this like that. You already have it installed. You keep freeze, let's see. You see that you have to take some very quick things. Yeah, I know. See? You see that? Java REST framework. Yeah, see? I think I would have to modify this REST framework. Yeah. Now you are seeing the difference between the library and the framework now. Yeah? Do you see the difference between them? Django is the framework. The other ones are libraries. What we have been using before are libraries. You see that now we already have the codes, all the boilerplates of all the codes that we need. You don't create things in Django now. You modify things. They will give you all the structure. See all the files, the view files, URL files, they're already there. That's why they call it a framework. Why they call some a library. You get the idea. Library, you don't have to define this, they just from use. They will create all the function for you somewhere. You just deploy them, import this one, use them. But when you come to a framework, they already have the way the project is already structured. So if you look at the Django project, most likely going to be this one. You get the idea. So most likely you just modify files, point to different directions, create functions inside Python. That's exactly what we are going to do. So when you add new things, knowing that when you add new things to a Django project, now you have to register it inside the Django project. Are we there? Alright. Okay. Now Next step. If you go to your project folder, right? Because we have just added new thing to Django now. Are we there? If you go to your project folder now, you see, now notes, sorry, I need to re-explain that part very well. Now, why I will need to set this up now as a different app now is because even the Django REST framework is a framework on its own. Are we there? It is a package on its own, not a library. If it were to be a library now, I can use it without setting it up. Did you get the idea? Just import and start using. But anytime you are using a framework inside another framework, you have to register it as an app inside. Do you get the idea? So each of those apps that we are creating now is just like they are a framework of their own. Are we good? So I would have to register that inside here now, inside my settings file. Where is it? If I go to my project now, are we there? That's my project folder. Inside it, inside the settings now, I'll see where you see, these are the settings for my project, for this particular project. You see settings there. So you can register, you see installed apps. These apps comes by default. You can see admin. This is for the admin dashboard. Django comes with a very lovely admin interface. Lovely one. You don't need to build admin dashboard. The way you are creating database is going to be showing by itself. They have the app already, guys, so they have registered it there. So what we just need to do is to just copy one of these lines, the way we did for that one of these lines, I installed app, paste it, then change it to the name of our app. The name of our app that we just installed is Django REST Framework, right? But this one, we are going to add REST Framework. No, we are not adding it. Just, this is the name. I don't know why it is like this though, but probably because they have another something like Django that has that name. So, I think you should write this one down. REST framework. Now, one step, add REST framework to your setting. So, we should have it identified already. URLs, okay. Now, let's go and create our view now. Are we there? Let's go and create our view now. Yeah, it has been registered like that. Django REST is aware of Django REST like that. Now our view. Where do I find the view folder? Where do I find the view that time? It's going to be inside individual apps, right? The views for each app. So it's going to be inside this crop API. So if I click it, I'll see a view file there, right? Open that view file now. Are we there? Now, the idea is this. I'll do this. I want to export. Are we there? Yeah. Oh, it's not showing. From Django now, I will need something called HTTP. And I want to pick response from it. Are we there? Remember that I said we need what? We need response. That is what I'm going to give out from my view. Are we with me now? So, I'm going to import that first. Are we there? Your file should look like this. Let me write this thing for you, the steps for you. Your documentation, what your documentation should look like this. What your documentation should look like this. URLs. Our URLs is inside web project. We are creating a URL inside it, right? Now copy and paste the URL, right? Right? Then change the path. Good. Then the second one now, we go to views, right? Views is inside where?
Inside the app.
It's inside the app. Django app itself. Django app. So it's inside the app. What did we do first? We import response, right? Import response. That is, let me click the code. Import, sorry, from, that one is found, that one can be found here. To import response, we go from Django.http, import JSON, yes, JSON response. See, what we just need to remember is from this HTTP, the Visual Studio Code will complete it for us. .http import JSON response. So I'll write that one here, which is import, from Django.http import JSON response. Are we good to go? Are we good to go? So I say your documentation should look like this. These are the files we are modifying. We are modifying the URL files and we are modifying the views file. Remember that we modified the settings file too. Yes, so I think this is an easier documentation to follow. So you just know the settings is inside where? It's inside our project. This is going to be easier documentation than that. So you know that when you are coming to create a URL, you are looking for the URL files, and your URL file is inside your project. What do you do there? You copy and paste one of the lines inside the URL already. Copy it, paste it. Then what do? We change the path. Did you get it? It is admin / before. If what we need is predict path, we just change that to predict. Are we there? Did you understand that? Okay, this is what I mean here. For that first part, the URL part is inside our project. This is our URL. Where is it? You see a URL file there. Click it open. Now I just added this to it. By default, it will come with 1 already. Are we there? So what we just need to do to create a new path now. To create a new path now, we just do this. Copy. Are we there? If we copy, Ctrl C. If we paste it, I will just change the path. Are we good? Instead of having admin now, I can just say predict. Did we get the idea now? Eh?
Yeah.
Change the path, then 2. Add the view. Point it to a view. Point it to a view. What do I mean by point it to a view now? This is where we are supposed to add the view. Are we here? This is where we are supposed to add the view. But I don't have the view yet. Eh? That's why I left it first. Are we good? So probably the best step would have been to go and create a view first. Then come back to create a URL. But we are familiar, we are good with this one, right? Go to your URL, copy and paste the URL, then change the path. Are we there? Then point it to a view. We don't have the view yet. Then we don't want to go and create the view now. We'll go and look for the view file. So these are basically the 3 things we are editing. Are we there? So we're going to look for the views file. The views file is where? Under app, right? The views file is under app. So if I go to my crop app, I will see a views file there. Did you see it? Click it open. Now inside this view now, because my view must return a response, I would have to import a response. Are we there? It is a Django, it is from Django, I will import it from Django. So that's why I'm like from Django.http, the response is HTTP now. What we send is HTTP request, HTTP response. Are we there? From Django.http, import JSON response. Are we there? Why are we importing JSON response? JSON is a universal language, a universal file sharing format. So if you return anything in JSON to somebody who's developing Java, he knows what to do with it. Java has JSON, C++ has JSON, all the programming languages have JSON. So what they just need is that data to just come in JSON format. Did you get it? That's what we want to return. There's response. Django has response. So you probably, if I'm building a Django application, I don't want to, it's not that any other person will use it, it's majorly for the application. Like I want to display it for people to see. I can just display response. Did you get the idea? But when we are building an API that will know that several developers might want to connect or integrate to an application, mostly return JSON response. Are we good to go? Now, let's create a view now. Let's create a view. How do we create a view? A view is a function. So every time you direct to a website, they are directing it to a function. They are directing it to a function. So you just attach, they just attach that URL to a particular function. Are we there? So let's define the function def. I will say.
Was it the other that create you? You know, you will do everything
on top. You know, this is a comment now.
Okay.
Yeah, so I just want to put it under the comment. I can still put it on top, but it wouldn't make sense again if I write the comment, create. This one doesn't have any effect. It's just for you to just know that you are starting your creation. Every other thing here are imports. Are we good? So I'll just say def. Let me now define this thing. Let me say prediction. That's the name of my view, right? Are we good? Then I'll write I don't want to use a class. Okay, let me push requests. I would explain what I'm doing there. Okay, return JSON response. Name Abubakar Abdulkader. Age 15. Data scientist. All right. Yes. Now this is my view. This is what is serving as my view now, a function, a Python function that is doing something. Now whatever that thing does now, the result of it is what it returns. Are we there? Now I would have are we there? The name of the function. Yes.
So we should write about
You can write anything. I'm just using this one as a template. So these are the details I want to return. If I run this code now, I'm expecting that anytime anybody visits this thing, visit that link, is going to get this data. Are we good? So this is a function the function name Abdul. Now, there's always a default parameter that comes with a view now. It's a function, but we need to pass in. Because each time they are calling, they are going to call our view. They are automatically calling it with a request object. So that request asks information about all the request type. What is the request type? What is the kind of device that you use to send the request? All of this inside. So we need to provide space for them. Did you understand? Did you get the idea? When we are defining functions, we define them, we put the different parameters that we are expecting. Now, if they are going to call it, they are going to call it the request object for sure. So we should provide that one. So that's why I have a request here as an object. Are we there? Are we good? My please go. Are we good? Now notice now that I didn't do any computation. This is a standard Python function. I can do anything inside here before I do my return. Who still remember? That's why I used to say that Python, I don't just trust all of us in Python. This is just a standard Python function. If you remember Python function very well. Python function used to look like this. There's sum. There's sum, A, comma, B, right? Which are the parameters now? I can do something like this. C equal to A plus B, right? Then I can do C equals to C minus 1. Then I can now do return. Remember? To return I can now do return C. Are we good? This is standard Python function, right? That's the same thing I'm trying to replace here. The name of the function. Are we good? Now I am expecting a request from them. Request information. That's why you see that sometimes you go to somebody's site, they have information about your entry. Everything about the request is stored here. What type of request is it? Is it post request? Is it get request? Is it? Are we good? Is it post? Is it get? Is it this? It should be inside here. Are we there? The time that the person makes the request, the kind of device the person used to make the request, all should be inside the request. So we should provide this. We should provide, because it's going to call this function. Remember that we still call the function. Remember, this is just creating the function now. To use this function, we must still call it somewhere. A code in Django is going to call this function. So it is calling this function with these parameters that is going to be here. Are we there? Did we get the idea? So now what are we returning? Is what you are going to return. You are returning a JSON response. After every computation, for an API, we are expecting a JSON object from you. You can do lots of things behind underneath. Carry this one, add to this one, carry this one, do it to this one. But at the end of the day, whatever result you are bringing out, make sure it is a JSON. What is JSON format? JSON is in this format. JSON format is like this. Do you remember dictionary? JSON format is a dictionary. Dictionary. You remember dictionary should have key, value, comma, key, value, comma. You get the idea. That is it here now. The key is the name. The value, the key, the value, the key, the value. Just see the beginning and the end. Or is it because I splitted them on different lines? I don't want it going all the way down. That's why I did it like this. And most times you can break Python codes where there are commas. If I break it here, it's going to be problematic. It's going to give me error. But after I break comma, I can put in there. So I just decided to leverage on that. If not, it can be one line. I can just have it like this. Okay? So this is me just returning the object. get, this is where the JSON this thing closes. You see, that's the JSON response function. I just throw the object inside. I just throw the dictionary inside the JSON object. This is the same thing as return. See now, return JSON response. Remember this? I just called that JSON response that we have imported before, right? So I now call it to the dictionary. That's what I want to respond. Are we good to go? Are we good? So now, I actually don't know if this will work or I've made an error, but if it doesn't work, we are still going to modify. Alright. So I will now go back. Remember that I didn't complete my URLs, right? Remember, I didn't complete my URLs now. So inside my URLs now, I would import the view. Because this file now we don't have access to where that view is. Are we there? I will do something like this. Import from crop API. Import prediction. Do you understand what's going on here? This is the function I want to use. It is somewhere else. Remember that this is the view now. Remember that I wrote it somewhere else inside a particular app now. Then we are going to import it from that app inside our inside our view, inside our URLs file. Did you get the idea? So if I add it here now, I'm just going to pass it here, prediction. Hoping that it's going to work. Yes. Now I'm saying if you come to this part, predict, go and run this function for me. Simple. Simple. So when you hear them say, create an API for us to do this, this is exactly what they are saying that they should do. Just, yes, exactly. So each time, so anybody that is building an application now, we just need, let's start. Let's run this before we see a big error. I'll go back to my command prompt and do run server. Run server. Do I have run server? Python, right? Manage.py, right? Run server. Oh, I have a error. I have a error. Okay, what's my error like? I don't know what this is like. And Django error can be very difficult to get. What's this? From Django to import. Import error. Where? Import error. Where? Where is error coming from? From Django.url. I think I should need to put dot here. I don't know. Let me still run and see. Do I have error? No. Let me see it again. Where is the one that I just ran now? Let me do the one, Ctrl C. Ctrl C. Create two more URLs. Because it would have been a lot lovely, I think we would have done post request. But this one will not be returning same, just normal string. Create two more URLs. One of the URLs should be train. The other URL should be process. You know, we can do something like this. That we can automatically be training our model without doing all those cleaning, anything. We can automatically be training the model. I'll just create a function, train, inside, put all the code to train the model inside, and have it as a API. So that anytime I just call /train, it will automatically call that function. So that will train my model and save a new one for me. You get the idea. So just create a model called train, create a model called process. Now return. Let me even challenge. Go and learn Python. Because I'm not giving you assignments, don't make us go learn Python. The first step inside this function is print model training. Print model training. 2 count 1 to 50. Print 1 to 50. Are we there? Then 3. Say model training is complete. Can we do this? Nah, we cannot do this inside here. We cannot print, we can only return. We can only return. We can actually do. Yeah, we can actually do. But if you do print now, it is going to print on your console, not to the person. Did you get the idea? If you do print, if anything running on the server, when you do print, it's going to print on your console. On that console where it is running, that's where it prints. So if somebody sends request now, they are not going to see whatever you are printing. Whatever you are printing is going to be on the console. You get the idea? It's only whatever it is that you will return to them that they are going to see. So I still want to do it, I still want it that way. Print model is training. Model is training. Then print count 1 to 50. Are we there? Then print model training complete. After you are printing model training complete, then number 4, return object. So the object you are going to return is you return the name of the model that you have trained, a brief description of the model that you have trained. Are you there? Then the size of the model, just random parameter. Do you understand? Do you understand the task now? The task is this. We are going to create a URL. Are we there? The name of the URL is going to be train. Now, add one new URL. Then go to your views page. Are we there? Now we'll create a new view now, a new function now. Then you do this. In the function.
Which is Python.
Yes. Oh, this is Python. This is pure Python. Forget that it's Django. Everything you do in Django. If the whole Django is Python, whatever they are doing here is Python. Just because they are not familiar with Python, that's why it's looking like they are doing something. It's just that they are written code that we are supposed to write for us. They just want us to fill in the blank with our own code. Are we there? So we'll create a new view. like you can create a different one, but it's better if you do copy and paste, retype, so that the whole thing is going to stay very well. So create a new view now. You know this one, I didn't do anything inside this function. Eh? I didn't do anything inside this function. I just returned something inside this function. But from the assignment I'm giving now, I want us, before we return, print something, print model is training first, then print 1 to 50, count 1 to 50, like you should print 1 to 50. Are we there? So the third one is, after the 1 to 50 is complete now, print model training is complete. Are we there? You can run Python function. This might not be 4 lines. It can be a whole lot of code. As long as they hit that URL, this whole lot of code will execute. You get the idea, and they are going to see whatever it is that you have been working on. So this should be a plus. This should be a plus for you because you are already in front end already. This is majorly backend. So if you say somebody tells you that I'm working on the backend for you, this is exactly what you're doing. You that are on front end now, they will just be giving you the link. Go to www. Like this new one that we just create now. If we host it now, I can host it. Let's say we host it at www.model.com. www.model.com now. To access that our particular link, now it's just going to be /predict. This is the link I'm going to give to any developer. Once they access this place, it's going to bring that information out for them. You do get the idea. So whatever it is that is inside the database, the front-end developer don't want to know. It is your own work. Now, anything that we want to do with the database, collect everything from the database is going to be here. There is Python code for connect to the database, or connect to the database from there, pick information from the database from there, return it from there. What the developer just wants to see is the link. You know where to get the file for URL. The file for URL is inside your project, the Django project that I just created. I wrote it on the board. You sit inside Django project. If you cannot find it, open it, open all of them, open all the folders really there. You see URLs there. Add a new URL. If you go to your API, the new app that you just created, you see a views file there. You modify it. Then you modify your settings file, add the Django REST framework to it. Now that should work for. So you are not creating one link, you are creating 2 links. You don't need to create 2 different projects for this one. Are we there? You don't need to create different project for this one. Different project for this one. You can create inside the same project. Just add another link, copy another one, paste them again. The same way you created this one, just do it again.
When I'm getting the link finally, I'm pasting it to the browser. The result of the command is
Now, wow.
like
See, I dey come. You want to create another API, another link. Control C. No need. Just paste another one. Change the name. What's the new link that you are creating? Home.
And what I'm saying is the output now.
Which one? The output. You direct it to wherever you want to direct it now. Go to the views, create another one. Control C. Paste it again.
No, like you don't understand what I'm saying.
What are you saying?
Like when you run it in the browser,
Mm.
the result is not going to like give us the result of the customer project.
Why should it give us the result of my project? Because here I'm changing it. I'm removing prediction. I'm calling it a different thing. I'm calling this one say home. So here now I'm now returning home is loading. Home is loading. Control S now. I come to this place now. I create another import now. See who now. Just the same thing that you have done before, just repeat them again like that. You keep repeating for everyone that you're repeating. Now from this place now I'm bringing in home now. Now put home here. put home. So I'm redirecting this one. Instead of direct this one to prediction, I would redirect this one to home. And when I run this, if I go to home, if I go to this place, /home, did you see? Didn't it home is loading? If I want to still add a new URL, I will still copy this one again. Control C, paste it. I can create 20 URL in 2 minutes now. Race, go to my view, copy on this one again, paste them again, Control V, edit it. What's the name of this new view? Let's say race now. It must not be the same thing. I can call it anything. Let me call it plants. I will say I am planting. Say I am planting. Remove this one. I'll say I don't need it. So if I save it, come to this place now, bring in the new the new view. It's going to be plant now. So come here, call this one plant. You see, I'm redirecting that race to plant, the plant view now. If I run this, if I go here and I make this place race now, it's going to print, it's going to do what? It's going to direct it to that plant. Can create 50 of this in 2 minutes. So it's not as if it's hard, it's just mastering all the steps that is there. And you can start creating a new project and finish all the new projects within 10 minutes. Are we there? You want to add another link, repeat all those steps again, copy new URL, paste it, change the distance, go to your view, copy, define a new function, paste it, finish. Have you terminated?